Hey guys, welcome back. This is Joel, and in this video, we'll be talking about EIGRP. Uh, these are some of the things which we'll be concentrating on. We'll also get some hands-on experience, trying to configure some of the speech features, right? Okay, so to start with, EIGRP is I would say it's an advanced distance vector routing protocol because it combines the aspects of the link state as well as the distance vector algorithms. It's a Cisco proprietary routing protocol, EIGRP, right? That combines the advantages of, like I said, link state and distance vector. So EIGRP may act like a distance vector, may act like a link state routing protocol because it uses the hello protocol to discover neighbors and form, neighbor relationships, and because only partial updates are sent when a change occurs, right? You don't send the entire routing table. So that's why you can categorize it to be like a advanced distance vector, right? Yeah. So how does it work? It establishes your neighbor relationships, with its directly connected neighbors, sends the routes, gets an acknowledgement for the routes, right? So then after that, it then keeps on sending keep alives or allows to let the neighbor know that it is up, right? And all the routes that were sent are still valid, right? In case of a new route comes up or a route goes down, the router will send an update to its neighbor only with the change, not the full routing table. That's something very interesting. You don't in EIGRP, you don't send the full routing table, unlike RIP. To establish relationship, EIGRP runs with the autonomous system. So this number is specified in the EIGRP setup and it needs to match on both the neighbors, right? So let's go down and do a bit of configuring. So we have like router, if you see the diagram, R1 and R2. So let's pick up this R1 and start putting in some configs down here. So let's look at what do we have. So if we do a show IP interface brief, we get to know the various networks down there, right? So let's go and configure. Let's call this as router EIGRP. Let's give the autonomous number, which is 100. Probably remove auto summary, right? Let's remove auto. We'll talk about summarization later. For now, let's remove auto summary, put in the network command, and the thing here, interesting piece again, right? In case of RIP, you would have seen in my previous video, we had the flexibility of only mentioning the major networks, right? If it was for the 10 network, you were supposed to write 10.0.0 because this was the major network, right? But in EIGRP, we can do this, right? We can do this. It's not that we can't do this. We can do this, but on top of that, we have the flexibility of mentioning the subnets as well, which means in this case, if I want to advertise this network, I can just go down and put in 10.1.1.0, sorry, and put in the wildcard mask, which is going to be 255, right? I can do this. This is acceptable. And if I want to do the same thing on my 12, right, so I can do that, right? What else we have? Probably I will not enable it on this network, right? So I just want to explicitly tell you that by doing this we are basically trying to limit enabling EIGRP on this network. So that's why I'm not explicitly going to do this. So I've enabled EIGRP on this one, and I'm going to do it on the 11 as well, right? So let's do it on the 11. Probably I mean, like I said, we can do it the way we used to do in RIP, right? So I'll do this that way. Just need to mention your major network, as simple as this. There you go, that works. What about the 101 network? Right, you can do it similarly. 101, it's a class A, right? So you do it this way. There you go. So we have done that, right? Now let's go down to my R2, clear the screen a bit. Let's enable show IP interface brief. Let's go to the configure, router, EIGRP, the autonomous number should match. Okay, no auto summary, right? Cool, that works. Now we have to put in the networks. Okay, so let's just blindly enable it on the entire major network. Let's do it on which one? 10. Yeah, so let's do it on what networks do we have? We have 192, right? So let's do it on 192 1.23.0, right? Probably we'll have to do it on the 22 network as well. So let's do that. 22 dot 0 dot 0. Great, that works. Okay, so there seems to be an error. Let's see why do we have that. Alright, so you can see my diagram. Ethernet 0/0 was supposed to have a different, okay, so I think there's a there's an issue with the interface. So let's me correct that. So the Ethernet 0/0 interface is supposed to be 10.12.12.1, oh, no, 2, right? 0, no shot, right? That makes sense, right? Now you can see the neighborship has come up. There was an issue with the address, and this one has to be the 0/1 interface, right? So let me correct that. Interface 0/1, okay. IP address is going to be this one. Great, awesome. So that looks good. Clear the screen a bit. So now you can see on my R2, if I do a show IP EIGRP neighbor, right? Let me do that. So if I do show IP EIGRP neighbors, I need to have a neighbor. You can look. So I have my neighbor, which is my R1. So R1 and R2 have formed the neighborship, EIGRP neighborship. So hello packets are sent every 5 seconds in EIGRP, and if a neighbor kind of misses 3 hellos, then you basically literally call your neighbor as dead, right? So that's what you can see here. This is the whole timer, right? So like I said, hello packets are sent every 5 seconds, and if you miss 3 hellos, so that's why you see this whole timer will never increase beyond 15, right? And it will always be in the range. If I hit this repeatedly, you can see it will be in the range of 11 to 15, right? So that's pretty interesting. What else? The other thing is, if I show you show IP route, let's look at show IP route, and you can see the EIGRP routes here, and EIGRP routes will always have an admin distance of 90, right? This is pre-configured for a protocol, right? For RIP, I think it was 120 if I'm not wrong, and lower the value, better it is, better the protocol, right? Cool. Okay. Summarization. So the summarization principle, or auto summarization to be specific, works exactly same as RIP. I could probably show you by disabling. Let me do that. So I'm inside the router. So if I do auto summary, right? So I have enabled auto summary now, right? Probably go down and do that same thing here as well. Right, so now if you see my routes, right, so you can see here the concept of auto summarization. So auto summarization works only when the route is crossing the major boundary, right? So auto summarization, so you see the 11 route here, right? It is crossing the major boundary because it is going through the 10.12 network, and that's why you see on R2 it has been summarized, right? Look here. Whereas the 10 networks, the various 10 networks which you have here, 10.1, 10.1.2.1, when it is passing through this, right, it is not crossing the boundary, and that's why you have those networks specifically mentioned here, right? Let me go back and actually disable auto summarization. I actually don't want that. There we go, I just removed it. That's cool. Moving on. What else we could talk is, we'll talk about the passive interface, right? Passive interface is again pretty interesting. Is it very much the same? So there are slight differences when you compare to the RIP protocol. In EIGRP, passive interface blocks both sending and receiving of EIGRP unicast and multicast, right? Which was a different case, in case of the RIP protocol, right? In RIP, only the sending was disabled, but here sending and receiving of EIGRP unicast and multicast, updates. So how do you configure this? We can go down to R1, right? We are inside R1, probably inside router as well. So let's make this passive interface default, right? This basically makes all my interfaces as passive interface. Now I have to obviously remove, or basically I need to because this particular interface is connected to R2, so I can't make this passive interface, right? Because I want the updates to be sent. So let's make it no passive interface on that particular interface, right? 0/0. There you go. And yeah, so by doing this, you can see the neighborship has come up again, right? Now, what if you want to do unicast rep, right? Unicast rep, unicast EIGRP, my bad. So let's say you want to do unicast EIGRP only between R1 and R2. So in that case, you have to add another command, which is the neighbor command, right? So right, so you basically need to use the neighbor command, and obviously you don't have to, you basically need to remove the passive interface command which you put on the 0/0 interface, right? So let's try that. So, and also the other thing is, for unicast EIGRP to work on both the sides, you need to configure the unicast EIGRP, right? Having one side multicast and the other side having unicast would not work. Okay, so yeah, let's try this. Let's remove, so we have done no passive interface, EIGRP, so let's probably put in the neighbor command, and 10.12.12.2 Ethernet, the interface, right? It's going to be 0/0. Okay, so this thing went down, and like I said, just doing it on one side is not sufficient, so let me clear the screen a bit. What do we do on the other side? We do passive interface default, right? We make no passive interface on which ones? Ethernet 0/0 and the 0/1, because these are the two interfaces which have neighbors, right? You want to send updates on these. Okay, and then you go and do the neighbor command on who is your neighbor? My R1 12.1 Ethernet 0/0. Okay, there you see the neighborship has come up. So that's how you can like configure unicast rep, right? Because you have configured passive interface on rest of the interfaces, on those interfaces there won't be any kind of updates being sent, right? And because of your neighbor command here, you'll be sending unicast EIGRP updates. Okay, great. Moving on, let's do a bit of authentication. So you can do authentication very similar to RIP. Let's try to do that. So we will start with configuring a keychain. Right, let's put a keychain. Let's call this as ABC. Let's also put a key string. Sorry, key. My bad. Key ID is important. Then you do a key string. Let's call Cisco. Right, there you go. And what else? Now we can go down to the interface where you have the EIGRP running. Excuse me. IP authentication would be the mode. The mode is important. You need to put the mode. And EIGRP, what is the autonomous number? 100. The mode is we're going to go with MD5. We will also look into the SHA part of it later, but for now you can just have a look at this. So there you go. So we are going to do a keychain, right? Put in the EIGRP 100 and ABC. Now when I hit this, you will see the EIGRP going down. There you see the EIGRP went down. Now this will come up only if I do the authentication related commands on the other side as well, right? So first we'll start by putting the keychain. We can call the same name or different. This is just locally significant, so you can even use the different name. The key ID has to be the same. Key string should be the same. Cisco. You go to the interface, right? You're gonna start putting IP authentication. You're gonna put the mode. You're gonna put the EIGRP 100 MD5. And the other command is the IP authentication keychain EIGRP 100 and ABC. Give it a second, and there you go. The neighborship has come up. So which means our authentication worked. So that's how you do the authentication of in EIGRP basically, right? Yeah, the other point which I want to call out here is that EIGRP doesn't support clear text, or does not support the clear text form of authentication. You always have to hash it. That's why we use the mode MD5 here, right? So by doing that, we're basically hashing the password. Great. Filtering is very much similar to the RIP. What I've actually covered in my earlier RIP videos, you can refer to that. It's very similar to that. The concept of filtering here is basically trying to filter out which routes are permitted and which routes we want to block, right? Basic understanding is that if R1 is sending certain routes to R2 and you don't want certain routes, to be seen on R2, then you can filter it, put in you either using access list or using prefix list, right? And thereby you can limit those routes being sent to the other guy or received from the other guy as well. So I'm not going to cover that again because it's something which I've done in detail in the previous one, and we will probably move on to the next concept here, right? What else do we want to talk about? We will talk about summarization now, but we'll talk about manual summarization, right? What we did till now was auto summarization, but what if you want to manually summarize, right? For that, we'll look into probably the R5 and R6 here, right? So yeah, let's go and enable EIGRP on R5 and R6. It's my R5, right? Let me go and see what do we have here. Show IP interface brief, right? You have stuff. Let's go and enable router EIGRP probably 100. Network, what networks do we have? I see the 10 network. Let's go and enable it on the 10. I also see 55 networks, so let's go and do that. Probably the 105 as well. What else? I also see 192. The major network is 192.1.45.0. The other one is your 56.0. Make sense? Yeah. Now let's also do the same thing on R6, right? Let's see that. Enable show IP interface brief. You can see a bunch of networks here. So I'll also show you a trick in case you want to like enable EIGRP on all your networks. How would you do it? Using just one line of command. It would be network, use the mask and say 255, 255, 255, 255. So basically now enabling it on all of them, right? So be careful because any new network you add to R6 also will get EIGRP enabled on it. So, but there's a quick trick if you want to do it on all of them, right? Great. Now looking at the network, let's go back to R5. You see that you have a bunch of routes here, 4, 5, 6, 7, right? If I do a show IP route here, you will see the routes from R5 coming to R6, right? You have 4, 5, 6, 7, right? Now I want to summarize this. I want to manually summarize this, right? We talked about how we do the bit-based summarization in our previous video, right? So again, pretty much a similar thing what we are going to do here as well, right? So how do we do this? Let's go down to my or we could probably do this on let's see yeah, actually we can actually do this on R1 and R2. Let's do the summarization, manual summarization R1 and R2, because here also you have the same network. So I'm going to show IP interface brief. Yeah, so there you go. So we have 101, 4, 5, 6, 7 network, and if you look at my show IP route, you will see that all those networks are seen here, 101, 4, 5, 6, 7. But I don't want 4, 5, 6, 7. I just want to summarize into one single entry, right? So go down to my R1. How do I do this? Which is the interface we are interested in? The 0/0 interface, right? So you go down to the interface 0/0, and the command being IP summary address. You need to mention the protocol EIGRP, the autonomous number 100, and so when you summarize, what will be the summary address, right? We did this in the earlier section. This thing, it's going to be very similar. I'm going to directly use here, but you can put all the addresses in a notepad and try to figure out the summary address and the summary mask, right? So we are trying to summarize, like I said, we are trying to summarize the 4567. So I'm going to use, it's going to be 4.0 is going to be the summary network address, whereas the mask is going to be 255, 255, 252, right? Refer to my RIP video for how did I get the 252. That's pretty much the same, right? So when I hit this, what happens, right? So there was a change, it's going to resync, and if I hit my show IP route here again, you will see that under 101.4.0 network we have just one entry now. Earlier we had 4 entries, but now I have summarized it into just one entry, right? So that is manual summarization. But let me call out the difference between this manual summarization in RIP and EIGRP, right? In RIP, if you remember, you were not supposed to summarize major networks, right? But in EIGRP we can. So that's something interesting, isn't it? So let's look into that. So we have R3 here, show IP interface brief, right? So I have my R3 with a bunch of networks here. So I'm going to enable RIP on this, sorry, EIGRP on this. I keep on saying RIP because that's something of a video I just did earlier, right? So let me just go and enable, give me a second on, yeah, there you go. Let me enable the networks, right? Let me enable your, do I already have EIGRP in this? Let me check. Okay, we don't have. So we just need to enable. So let's put 192.1.34.0 and it's just a major network. I could directly use this. 23, probably enable it on the 10.0. It's good. What networks do I want? Let me just enable it on the 200 network for now. 200.1.4.0, 5.0, it's going to be 6 and 7, right? If you look here, this particular network, right, the 200 network, these are all are these subnets or major networks? These are major networks, aren't they? Because it's the first octet is 200, right? It's class C. So each of this loopback is actually a major network. Now let's see if we can summarize this, right? Let's see if we can summarize this. So let's summarize this towards so I'm on R3. Let's summarize this towards R2. So let's go down to the interface Ethernet 0/1, right? And IP summary address EIGRP 100, right? And 200.1.4.0, and my summary mask is going to be like similar one earlier which I used, and there you go, it allowed me to summarize. If you remember in RIP, when we tried to do this, we actually got an error, right? But in case of EIGRP, that's a difference. You are allowed to manually summarize even the major networks, right? Just remember that always you do the summarization per interface though, right? It's not under the router command, you do it under the interface. So the next piece which we are going to talk about is the metric calculation in EIGRP. All right. So let's look at the small network here, right, consisting of R4, R5, R6. Observe that I have provided a different bandwidth for a couple of the links. So for example, here we are using the default 1544. Here as well on this link, it's a serial link, so we're going to keep it 1544 kilobits per second. Whereas here I have changed the bandwidth to 128 kilobits per second, right? So so what we're trying to do here is that we're trying to calculate the metric, which means when a route basically goes from my R5 to R6, right, there'll be a metric associated with it. There'll be a metric calculated, right? So R6 is going to calculate a metric for this particular route, right? So how R6 is going to calculate is what we are trying to do now, right? Great. So let me tell you. So there is a formula. There's a very simple formula. Let me write down the formula here. So the metric calculation or the value metric is actually calculated this way, right? It's 10 to the power, you can say it's 10 to the power 7, right? That's actually, let me put a bracket down here. It's 10 to the power 7 divided by bandwidth or minimum bandwidth. I will explain what that is. It's minimum bandwidth and plus delay, right? It's a standard value for different links. It's the sum of the delay, right? Let me mention it as sum of the delay. Then divide that by 10, right? And close the bracket. The whole value multiplied by 256, right? This is the metric calculation, right? So now if you go back to our um, topology, right? Let's say we are talking with the route 105.1.4.1. So when this route is actually going like this towards R6, now what is the minimum bandwidth involved, right? So we need to know the minimum bandwidth. Okay, so if you look here, this, let's assume that this is basically nothing but a loopback address, right? The 10.105.1. whatever network, this is a loopback address, and they have a very high bandwidth of like 8 gig, right? So let's so the only minimum bandwidth along this path is basically nothing but the 128 kilobits per second, right? So your minimum bandwidth is always the minimum bandwidth along the path. In our case, it is 128. Let me go and write that, right? So calculation would be metric probably along let's just, it's okay, I'm gonna write just as metric equals 10 to the power 7 divided by 128, right? And let's add the delay. What's the delay? So so we are talking about only this path, right? Only this path right now. So the delay here is going to be 20,000, right, along this link. It's going to be 20,000 along the serial link, and 5,000, it's microseconds, right? 20,000 and 5,000. 5,000 across the loopback, because it's a loopback, right? So these are standard values. These are it's not something which I'm cooking up, right? It's standard values. So it's always 27,000 on a serial link, whereas it's different. The delay is different for different. For a Ethernet link, it will be 1,000, and for loopback, it is 5,000. So that's why you're adding 20,000 plus 5,000 over here. It becomes 25,000, right? So it's 25,000 divided by 10, right? And that's basically going to be 2,500, right? So now what we have to do is just calculate this and multiply it by 256 to actually get the metric probably along. Let's call this as the direct path, right? Because we are talking about this path, right, which is directly connected, right? How much is this? Let's do the calculation so that later we can put this configuration on my router. And so it's 10 to the power 7, right? Sorry, so the mistake, it's 10 to the power 7. So let's do that. So I have a calculator open here. So 10 to this power 7 would be like 7 zeros, 6 and 7. We're going to divide that by 128, right? And add 2,500 to it. Okay, there you go. And multiply this by 256. There you go. So that's my number, right? It's like around 20 million, sorry, it's around 20 million 640,000, right? So that's the huge number. Now let's try to do the same calculation, but where, let's try to do it for the other path. So if you look here, we have two paths, right? Between R5 and R6, there is another path as well, which goes like this. So if I have to calculate the same metric for the other path, how would I do it? So it's going to be metric for the, let's call it as the indirect path, right? And it's the calculation is going to be 10 to the power 7 divided by what is the minimum bandwidth now. So it's 1544, and probably 8 gig here. So it's going to be 1544, right? And we will have to add something, the delay. The delay is going to be 20,000, 20,000 and 5,000. So it's 45,000, right? So 45,000 of delay divided by 10, and all of that multiplied by 256. Great. So let's go back to the calculator. So it's 1000, sorry, 10 to the power 7. So we have 5, 6, 7, 7, yeah, divided by 1544. So you get 6476 and whatnot. Let's we always use only the decimal part of it, so we use 6476. So let's clear this. So it's 6476 plus 45,000 by 10 is 4500. 4500, right? Take this number, multiply it by 256. There you go. So that's my number. So that's my second metric over here, right? This is a quite small number, isn't it? So it's just 2,000,000 and 809,856, right? Make sense? Great. So now, as per the rule or as per EIGRP, always it prefers the path with the least cost. So in this case, it's going to prefer this cost. Now let's verify this. Is it actually that? Is that really how EIGRP behaves, right? Let's do this. So we'll go back to my router R5, right? On R5, I need to put a bandwidth of, the default is 1544, right? So I just need to change this on serial interface 1/1. So let's go down there. Sorry, enable config interface serial 1/1, bandwidth is going to be 128, right? No shit. And similar thing would happen on the other side as well, right? Sorry. There you go. So we have done that. Now we have to calculate the metric. We have calculated the metric. So let's go and do we already have EIGRP on this? If not, we'll have to put it. Right. So let's see. Do I have EIGRP? Show run section router. Okay, so we have enabled EIGRP already on this one. Show run section. Yeah, we have done that. So now let's go to R6. Let's clear the screen a bit and look at. So if we'll go and do a show IP route here, what do we see? You see that the 105 network from R5 is advertised or is reachable on the interface with the least metric, and the metric is very similar to what we arrived on. It is 2,809,856, right? So we have the same number here as well, right? And it is choosing this metric. So it's basically choosing to take the route which is this one, right? Because it has the least metric and it is not taking the direct route, right? Got it? So we have actually verified this space. That's pretty interesting, right? So yeah, so basically the other thing which I also want to tell you is what I did here was I configured the bandwidth, right? So I configured the bandwidth 128. So this doesn't mean that the line rate on that interface is 128 kilobits per second. No. So the line rate is actually decided by the clock rate value, right? So under the serial interface, you can go and actually configure the clock rate, and that is what is going to actually decide your line rate, right? The speed at which the data is going to travel. The bandwidth 128 command here has no relevance to that. It is just the number which will be used for the metric calculation, right? So the clock rate, if I have to show you, it is this command. So you go down to that interface, and there is a command called clock rate, right? So if you configure whatever you configure here, right, the 128 kilobits per second, so that will be the actual line rate of that particular interface, and that's generally set by the ISP, right? But to keep your EIGRP up to date and keep the calculations correct, it's always recommended you keep the clock rate as well as the bandwidth equal, right? Because at the end of the day, that is what you want. You want the EIGRP to take the actual line rate and kind of configure or use it in the metric calculation, right?